Good morning, lovely Niners. Right, buddies, here's the deal for today. We're going to continue to rock on through our percentages unit. I'm really excited. I actually get to see you guys again on Friday and then next week. So our online learning is coming to an end. I have to say you've been fantastic as normal with the online learning. So I've had really good turnout of homeworks, and I've had a few of you asking me questions over Show My Homework and everything. So you've handled it really responsibly again, just like you did the last couple of times. So really good work, awesome Niners. Cool, right, buddies? To start with today, we're doing a brand new topic, which is going to be compound interest, but actually, it's still linked to the percentages unit. Now, I'll tell you about that in a sec, actually. But before we move on, here's what I need you to do. I actually want you to try this starter. Now, really importantly, it says in the starter that you need to have what's called a multiplier. I hope you remember from last lesson what a multiplier is. It's a decimal number. It'll be like 1.2 or 1.5 or even like 0.8 or 0.6 or something like that. It's a decimal number that you can simply times the amount that you're starting with by in order to get the answer. That's why it's called a multiplier, because you multiply by it. Cool, cool, cool. So the answer to the first question, while it is 26, I don't want you just to write down 26. What I want you to write down is this. I want you to show me one step that shows you understand the multiplier, which is this. 20 pounds is how much we start with, so it's 100%. You don't have to write that, but that's how it works. And if you're going to increase it by 30%, that means in total you're going to have 130%. Still don't have to write that. Now here's the thing you do have to write. You have to write down this. You have to write down 20 times, and 130%, what's that as a decimal? Well, divide it by 100, so if you said 1.3 or 1.30, both are cool, well, that's the answer. Because now, look, you can cheat in your calculator. So we already know it's 26, but let's just confirm anyway. 20 times 1.3 equals 26 pounds, like an absolute boss. Cool. So what I'm going to have you do is showing this multiplier step, critically, this multiplier step for every single one of them. Have a little go at B, C, D, E, and the challenge. So you ready? Push, pause, and go. Okay, buddies, and you're back from having tried all of these. So quick as I can, I'll go through this. 50% decreased by 25%, so that's going to be 50 times by 0.75, because 100% take away 25% to get that. 50 times 0.75, 50 times 0.75 is 37.5. So perfect, 37 pounds 50. Okay. Now this one's tricky. 2,000 pound stock increased in value by 325%. This one's proper hard. This represents 100%. So when you add it to 325%, it's actually 425%. Now, I bet you not everybody got that. So the calculation then, 2,000 times by, divided by 100, so 4.25. And you get 200 times 4.25 equals 850. Ooh, that means I missed a zero, which means it's 8,500. That's better. So 8,500 pounds. Cool. Now, it is neat that you can have percents that are bigger than 100, and things like stocks or businesses or profit and stuff like that are percentages that will be above 100%. So essentially, this stock became, well, it was worth 4 times what you paid for it, because maybe you bought a stock in a company that was just starting out, and then it's turned out to be a very, very productive, good company, and people didn't realize that they wanted what this company was selling, and all of a sudden everybody wants it, so it's gained huge value. So that's how this works, my buddies. Cool. Someone earning 25,000 pounds a year got a raise of 3%. Let's see, it's 25,000, and a raise of 3% is 1.03, because it'd be 103%. 25,000 times 1.03 equals 25,750. 25,750. So yeah, they got a 750 pound raise. Cool. Cars depreciate in value very quickly. That's certainly true. Sometimes it's estimated that it's as much as 25% per year. So how much will your £15,000 car be worth next year? Well, lost 25%, so 75% remains. 0.75 is a decimal. 15,000 times 0.75 equals 11,250. Okay, and that, my lovelies, is a really big reason why tons of people buy cars that are used by a year or two. That's a really, really big business, used cars, and it's probably because of that. Because if you just wait a year or 2 or 3 years to get your car, you can get it for a lot cheaper than it would have been to be the first one who owned it. So that's why lots of people do that. Cool. Right, now here's your challenge, and it actually leads into the topic today. How much will the car be worth in 2 years? Well, my buddies, I bet you some of you got this. So in the second year, it starts off being worth 11,250, and then you end up timesing that by 0.75, and that means times 0.75, which means it's now 8437.5. Okay, 8437.50. Cool. What would you do to do the next 4 years? Well, buddies, what are we going to do? Well, what we'd have to do, I'm just going to tell you in the calculator, you can times by 0.75 again. That means in the third year, it's now worth 6,328. Then times by 0.75 again. And that means that in this year, it's worth 4,746 pounds. 746 pounds and 9 pence. Cool? Now 50 years. I wonder if anybody got it. I'm just going to tell you really quick what the answer is, and let's see if anybody got it. I'm going to show you how you do this. Times by, now it's 0.75, but how many times do we times by 0.75? In the first year, we times by 0.75 once, then we got an answer. In the second year, we times by 0.75 a second time. In the third year, you times by a third time. In the fourth year, you times by a fourth time. In the 50th year, you'll have times by 0.75 50 times. 50. Because that's what it means if you times over and over and over. So the answer to this one, times 0.75 to the power of 50, it's going to be very small. Oh, it's very small. It's 0.008, which rounds up to 1p. Cool! So our car is worth a penny after 50 years. How exciting is that? Cool. But anyway, that neat little trick here is what I'm going to show you right now, because our brand new topic, which you should put in your book, is called compound interest. Now, compound interest, so I'll give you a chance to write that title in your book. Also, I'm going to just talk over while you do this. You can probably do two things at once. Also, I want you to write down this table, write down years, calculation, and new value, and then 1, 2, 3, 4, but then literally put the dot, 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 don't continue all the way to 10. Go 1, 2, 3, 4, dot, 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 10, 40. Cool, 1, 2, 3, 4, dot, 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 10, 40. So get your table all ready. Now, here's the thing, buddies. Compound interest, see, while you're writing that table, I'm just going to talk quietly over. When you do compound interest, my lovelies, this is it's something that's really useful in real life, okay? This is how essentially all interest rates work in real life. So if you had money to invest and you had a good whack of money, you're really lucky and you got a big whack of money and you're going to invest it, what you'll get on it is compound interest. Here's how compound interest works. You'll put money into a bank account and say you put £100 in and it made 10% interest, which would be amazing. That doesn't really happen, but yeah, you put £100 in, at the end of the year it made 10% interest, and then it was £110. Now in the next year, it won't just be that £10 again. It won't be like worth another £10. It'll be worth more than that because the new amount's £110. So rather than making £10 in interest, now you'll make 10% of 110, which is £11. So you made £10 in the first year in interest and £11 in the second year. Cool? Now you've got £121. Well, with that one, when you make 2% interest on, 10% interest on £121, now you've made 12 and a bit pounds in interest. And you see, every single year, your money makes more than it made in the year previous. That's what compound interest works. That's how compound interest works. Now, unfortunately, it works two ways. It doesn't just work when you have money that you have saved. It also works when you owe money as well. So when you get something like a mortgage to buy in order to buy a house, on a mortgage, you end up paying a lot more than the house is worth because of the mortgage. Now, in theory, buying a house is always a good thing because even though you end up paying more than what the house was worth when you bought it, by the time you come to sell it, it'll be worth more than you bought it for, but also worth more than the interest that you paid on it. So it's a good investment to buy a house, whereas something like a credit card is a bad thing because if you didn't pay off your full credit card, you'll find that it ends up costing more and more and more every single month. So it's hard. You can see why some people end up in trouble. If you didn't have enough money to pay for your credit card, but you still spent on it, then that means that it's going to take you ages to pay it back, and you'll end up paying a lot more money than you needed to. So that's kind of the blessing and the curse that is compound interest, and this is actually how real life works. So how exciting. Anyway, here we go, my buddies. I've had my spiel, my rant now, so let's do this thing. Okay, you invest £500 into an account that's earning 5% interest per annum. Now, annum, my lovelies, just means year. It's kind of like annual, but annum is what finance people call a year. So it makes 5% interest per year. Fill in the table to figure out how much it will be worth in the future. Cool. So if you start off with 500 quid, buddies, let's do it. I need 3 colors at least, so that'll do. Purple. Let's go purple, green, and red. Okay. Here's what you're going to do, buddies. To start with, you get your £500, and if we're going to increase it by 5%, a multiplier that matches with an increase of 5% will be 105%, so 1.05, which gives us a total answer of, what's it going to be, buddies? You can do it without a calculator even. With a calculator, I did it, 525. So you end up with £525. What about in the second year? Well, I could take the 525 and then times it by 1.05, but you guys know that 525 is actually the same as the calculation itself, right? So here's what I'm going to do. I'm going to write 500 times 1.05, because we already know that this, buddies, that this equals that. So I may as well, instead of writing 525 there, I'm going to leave it as a calculation. But then what happens is I have to times by 1.05 again. 0.05. So when you do that, 0.05, you end up with 551.25. 551.25. Cool, the end of the third year. Well, here's what I'm going to do, buddies. I'm going to erase the highlighting first. There it is. And there it is. Okay. Now in the third year, here's what we've got. We've got the original 500. It was times by 1.05 from the first year. And then it was also times by 1.05 to the second year, and now it's also going to have to be times by 1.05 again for the year that we're on, because that's the same as 551.25, which is the first 3 things equals that. You're going to times that by 1.05, so times 1.05, and you get that the answer is 578.81. So you get 578, 578.81, 578.81. Whew! Well, this pattern is starting to get long and to be a bit of a pain, my lovelies. So I wonder if you can see a pattern. I wonder if we can spot it. In the first year, you times by 1.05 one time. In the second year, you times by 1.05 2 times. Third year, 3 times. Fourth year? That's it, 4 times! Oh, here we go. Check it out, buddies. It's going to be 500 times by 1.05 times by 1.05 times by 1.05 times by 1.05. Oh, I can't be bothered to do that all the way up to the 10th year and the 40th year, can you? No, I certainly can't. So, who's got a shortcut then? What can we do? I don't want to write it like that. Instead of writing it like that, how about this? 500 times 1.05 to the power of 4, you're right. That's the shortcut way of writing it. So all you're going to do is 500 in your calculator now times 1.05 to the power of 4 equals 607.75. 607 and 75 pence. Cool. Well, guess what, buddies? Now you can do it for any year at all. You've just unlocked compound interest. So if you want to know how much it's worth in 10 years, it'll be 500 times 1.05 to the power of 10. That's right. 40 years? 500 times 1.05 to the power of 40, because it was times by 1.05 40 times in 40 years. What are those answers, just out of curiosity? Times 1.05 to the power of 10 is 814 pounds, 814.45. And what about for 40 years? If it was 40 years, oh my word, it's worth an awful lot. 3519, 3519, 0.99. Cool. So in the end of 40 years, your money is worth a load, 3,500. How much do we start with? 500. So it's like worth 7 times as much in 40 years, which is way more than just having 25 pounds a year because of compound interest. Cool. I'm going to show you one final thing, okay? There's a special formula here, and it's actually going to be the nth term. Okay, what if I left it in for n years, any number of years? What would the formula be? Well, 500 times by 1.05 to the power of n. Boom. That's compound interest, buddies. All it is at the end of the day is you figure out what the multiplier is, and the power matches up to however many years it was saved for, or, in the opposite, however many years you had to pay interest for. Cool, cool, cool? Right, let's see how we're getting on then. Okay, these guys here. Check it out. Question 1. It says, oh, good heavens above, a lottery winner invests £1 million into a savings account with a 1% interest rate. That's pretty much what interest rates are right now, if you're lucky. But that's really quite low. You can do a better interest rate than that usually. And if they don't withdraw any money at all, how much will they have after 7 years? Well, here's the calculation, guys. What are you going to write? Well, to start with, you're going to write your million. 1, 2, 3, 4, 5, 6. We're going to multiply it, because it's a multiplier, by the multiplier. 1%, well, 100 plus 1 is 101%. As a decimal, 1.01. How many years do we do it for, though? 7? 7. Boom, let's see. Million times 1.0101, we'll get there eventually, to the power of 7. And you get this, you get 1,072,135. 1,072,135, and that's 35 pence. Cool. So actually, buddies, if you check it out, in 7 years, if you are a millionaire already, just putting your money in at a small amount of interest, in 7 years, it makes £72,000, which is loads. So I don't know if you've ever heard kind of the expression that rich people get richer, or the rich get richer. It's because, say that you were somebody, I don't know, like Alan Sugar, or somebody, or like Bill Gates, somebody who is a big millionaire, a billionaire even. You wouldn't have to do as long as you didn't spend your money like a crazy person, like buying everything, you can actually live on the interest rates if you have tons of money, because if it was $1 billion, that's 3 times more, so 72,000 would be 7.2 million per year that you would have, and that's way more than enough to live off of, like, my word. So these billionaire people can become super billionaires, and that's exactly what they do. How exciting for them. Cool. So let's do another one, buddies. A car depreciates. That means it loses value at a rate of 15% per year. How much will a £20,000 car, nice car that would be, how much would a £20,000 car be worth in 5 years? Well, let's find out. 20,000. And we need the multiplier. So if it loses 15%, how much does it still have? 85%. 85% is a decimal? 0.85. See how we've done that? And 5 years to the power of 5. What does it equal? Let's check it out. 20,000 times 0.85 to the power of 5, which is 8874.1. 8874.11.11. So our answer to that question then is our £20,000 car at the end of 5 years is worth £8,874. And that's quite cool. So the car's worth way less, which is why people sell, well, this is why lots of people buy used cars, as I say. So happy days, buddies. That's it for today. So essentially all you have to remember is what the multiplier is and raising it to the correct power. And all I'm going to get you to do today is two things. First things first, I want you to try this worksheet. I'm going to show you something really sneaky with it though. So an increase of 20, this is a funny one. It starts off being a bit funny, but an increase of 20% for 3 years, all it wants you to do is write down this, 1.2 to the power of 3. Okay, that's all it wants you to do. 1.2 to the power of 3, the power of 3 equals 1.728. Okay, that's all these first ones want. This one here, a decrease of 35%, that means 0.65% remains, times by a decrease of 20, 0.8, and then you get whatever your answer is there. That's how you do that. 2 is normal, and then this is normal, 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 and then this bottom one, a challenge, is really a really good challenge, a really tricky challenge. So I want you to do this sheet first. As soon as you finish with that, buddies, I want you to go on to your Kerboodle, to your online textbook, so book 3C in Kerboodle, and once you've got that done, on to page 65, okay? All of these questions, so 1 to 5. Now if you still have time at the end because you're really slick at this, then you can just play the My Maths game till the end of lesson. So really good work, buddies. Have a little bit of a go at that. I'm so excited to actually see you in person, stop doing online teaching. But again, really good work throughout. So that's it for me. Bye, buddies.